What's going on, everybody? My name is Johnny Bandon, and today or this week we're going to be going over CecurityX, formerly known as CASP. So this is our online training with Trepid Technologies. Before we go over kind of the course layout, what we're going to be learning, how to access all the material, make sure you have access to all of our practice exams, I just want to touch on this exam in particular and the changes from CompTIA. So it used to be called CASP, CompTIA Advanced Security Practitioner. It's changed over to CecurityX. Now, the new version of CASP, which is now called CecurityX, that exam code is called CAS-005. CAS-005. That's the brand new cert that was CASP, got turned into CecurityX, but the exam code is still CAS-00 So this is the new cert. I will send this link in the Zoom chat as well. Okay? It's now just called CecurityX. This course that I had planned, we will be teaching CAS-004. Now don't worry, you can still take CAS-004 until July 17th, 2025. So it gives us 4 months, gives you guys 4 months to pass this version that I'm going to be going over and that all my practice questions apply to. Now, if you pass this exam, which is what we're training for, you automatically will get this one. And you'll get a CecurityX certification in the mail, and you will be CecurityX certified. Okay? As of right now, you can take both. I'm training you for this one. Now, whether or not you purchased this off our website, or you got it funded through your company or through Army Ignited, you're going to get access to this course that says CompTIA Advanced Security Practitioner. But since you purchased in this kind of weird transition period, when we launch the CAS-005 course, we're going to automatically enroll you in that new course that we create, okay? So you'll have access to the 004, and then when we launch our new course, you'll be automatically rolled over to the 005 course, okay? So if you don't manage to pass 004 before its expiration date, you'll be automatically enrolled to our 005, and the vouchers we're going to give you can apply to both. So I'm going to order you a CASP, a CAS-004 voucher. That voucher is going to be good for a year, and it will be able to apply to both exams, the 004 and the 005, okay? I hope that clears up any confusion. We're going to start a group chat together. And if you guys have any other questions, you'll have my direct cell to ask me, okay? But yes, so really you kind of have like 4 months to get 004 based off our training. Now, if you don't get it done in time, the voucher's still good to take this one, and we'll automatically enroll you in our new CAS-005 course, okay? Just want to get that out of the way. Now, as far as I'm going to bring up our Zoom chat here just in case you guys do have questions. As far as accessing the course material, when you want to access our course material, you can just type in Trepid Tech down here. You go to, this is like our sales front end page. If you click here to Academy, it'll bring you to a login to get to our learning management system. This is our custom learning management system that we have built for our students, that if you purchase our course, you get access to, lifetime access to. Now, if you're a first-time student, you'll just have CASP here. You'll just have the CompTIA Advanced Security Practitioner course on there. You may have additional courses if you're a previous student of ours. Now, you click Courses here, come to CASP. We're going to have the lessons here and the exams here, okay? I haven't built flashcards for this exam yet, but they're coming. It just is a brand new feature we launched at the end of January. So the feature's there, but we don't have any built yet, okay? But the important thing is these exams here, okay? I'll say more in our group chat because I'm also live streaming half of this, half the training for today. It's just a little like thing I do for our YouTube channel. Stream half of the first day of training to kind of like entice people. But anyways, I'll go over these exams more in our group chat just with the class, right? I don't want to give out all the secrets here on YouTube Live. But these practice exams, if you're getting 90% on them and above, you'll be able to sit the CASP exam. with certainty that you will pass if you're getting 90% and above on all these practice exams. So we have 11 total CAS practice exams with a master exam here. That's the total sum of all these, okay? So you see how each practice exam has 50 questions, and we have our CAS master exam, okay? We also have a dynamic exam here, which lets you randomize the order of our entire question bank, 25, 50, 100 questions. It's kind of another new feature we just launched. But let's go over these practice exams, okay? So this is how they look. Remember, you have lifetime access to this. You can redo these practice exams as many times as you want. There's no limit on it. It looks good on mobile. It looks good on tablet. It looks good on your computer. And we also have a mobile application you get access to. That's not public on the App Store, that only our students get access to. The way it works is pretty simple, okay? Typically, we will have an explanation here. I would say about 90% of the questions have an explanation. It'll show you the right and wrong answer. And we also give you the ability to leave a comment. So you can also leave a discussion comment here that is global. So maybe you disagree with my answer and you say, hey, Johnny, I think it is this. Or I think it is B. You can leave that discussion comment here, and every student that comes across this question on this practice exam, it's global. For every single student that has access to CAS will see that discussion comment. So you could be helping other students that are also taking these exams. Okay. Let's come back to the course landing page here. We have a Google Drive in here that just has like the downloadable slides and things like that. I'm also recording all the Zoom sessions, so all those recorded sessions will come in here. We have this tools page. It's just like other little tools here, some cybersecurity tools that if you want to come download from here, give you access to that. And then all of our slides are right here as well. So if you want to follow along, and the slides are right here as well. The slides are also right here too, okay, on the actual lesson page itself. Alrighty. If you don't have access, what we're going to do right now is we're going to put our cell phones in this chat. I'll start, and we're going to make a group chat, okay? I'll make a group chat, and you guys just message me in that group chat or message me directly if you have any problems accessing the Academy page, our learning management system, okay? And then if you do have problems, you never got a registration email, just message me your email as well. Since we missed a day yesterday, I may be going just a little bit faster. We'll still be able to get through all the exam objectives. And then, yeah, we'll end Friday, and I'll be ordering your guys' vouchers, and then I will assign your vouchers to you, okay? Do you guys have any questions? Okay, awesome. Now I'm going to go over how I'm going to teach this course. So I will teach for about 20 to 25 minutes at a time, maybe 30 minutes, depending on how quick we're going. And I'm going to take 5 to 10 minute breaks. That's the general flow. Day 1 to day 2, we're going to finish up domain 1, get into domain 2. Day 3, we'll finish up domain 2, get into a little bit of domain 3. And the final day, we'll finish up domain 3 and domain 4. Domain 3 and 4 are just the sections are a little bit less. You'll start to notice, like if we go over the exam objectives here, that domain 1, domain 2, and domain 3 are the biggest portions, so we spend the most time on them. And then domain 4 is kind of just easy. It's just memorizing a lot of governance, risk, and compliance, okay? So that's why domain 4 we can kind of take like I wouldn't say a half day, but we don't need a full day on it. When we go over domain 1 and 2, we cover a lot of the things that then are talked about in domain 3 and 4. Kind of the way I teach the cybersecurity lessons here is when I teach about something in domain 1, it may relate to something in domain 3. So I won't repeat myself as much. So you'll notice day 1 and 2 is a little heavy, right? And then 3 and 4 is a little bit less heavy because I might have already touched on something from that domain. Since we did miss Monday, next Monday, I forgot it was President's Day. Next Monday we'll have a makeup day, okay? So next Monday we'll also have a makeup day. I'll open the Zoom at 6 p.m. and whoever wants to join can join. That'll be a makeup day, okay? In case we don't finish everything, or we do finish everything, just to give you guys an extra day with me, maybe to go over questions, things like that, okay? Alrighty. So with that being said, I'm going to put 5 minutes on a timer here. After that 5 minutes, we're just going to jump right into it, okay? So get prepared, get mentally prepared, because with CASP, this is an advanced cybersecurity cert. So I'm going to be going full speed. So the assumption is that you have Security Plus, you have some years under your belt. This is the most advanced exam CompTIA offers. So as much as I would like to break things down Barney style, there's going to be a lot of assumptions that you know some of the cybersecurity basics, okay? That doesn't mean you can't ask questions. Feel free to ask questions, raise your hand, come up on the mic, whatever the case may be. But there's going to be an assumption that, we're going over the CASP objectives purely. And we're not going to waste time on something that should be fundamental, okay? So I'm going to put 5 minutes up here. And after that 5 minutes is up, we'll begin the lessons. And remember, in that chat, guys, put your cell phone number so I can start a group chat so I can interact with you guys, okay? Just in case anything crazy happens. I have a power outage, whatever. I need to be able to get a hold of you guys. If you don't want to put it in the group chat, just message me directly on Zoom, okay? Okay guys, so let's go ahead and get started. So we're going to be going over domain 1 first. If we take a look at the exam objectives here, we're going to be going over domain 1.1. I've split this up into 3 different sections, and I think you can see why, because there's a lot to go over. This is going to be given a scenario, analyze the security requirements and objectives to ensure an appropriate secure network architecture for a new or existing network. So we're just going over all the different services that we may have on our enterprise network that can help us with our defense in-depth approach to cybersecurity. Now, CASP is I would consider this a technical but high-level blue team certification. Not necessarily showing you how to use any appliance, like specific appliance, so we're not going to become experts in like Splunk or a SIEM or EDR, XDR solution. We're going to learn about, at a high level, all the different ways to apply this defense in-depth approach to protect our architectures, to protect our enterprise environments as far as domain 1 is concerned. So let's go ahead and jump right into it. So our objectives here, we got a lot to cover. So secure network architecture. So what we're saying here is that when we look at our modern day network architecture, so we're talking our not traditional, we're talking our robust hybrid environments. Things like having resources in the cloud, having resources in the enterprise, having a remote workforce, having PaaS and SaaS applications from multiple different providers. What are all the tools and technologies and protocols we can use to secure that network? Now, we're not getting into the human element here. This is all going to be technical controls that we're going to talk about. And we look at our different organizations that we may be securing. There are going to be a lot of different priorities. So we have to match the technical solutions to the priority of the organizations. So what do I mean by priorities of the organization? What we're talking about here is that as cybersecurity professionals, we're not revenue generators. So what that means is we have to sing to the tune of the organization we're supporting. And depending on the industry, depending on the stakeholders, depending on the C-suite, and their definition of priority for technology and cybersecurity is going to determine what architecture we're securing, how much money we get towards it, what resources we have available, and what we can do. So keep that in mind as we go through this course, okay? So now let's just get into it. First, we're going to go over load balancers. So load balancers are a hardware appliance or a cloud-based appliance that's going to distribute TCP and UDP sessions across a web server farm. In its most basic definition, load balancers distribute incoming network traffic across multiple servers. This ensures that no single server becomes overwhelmed. This is an availability solution. So we look at our CIA triad: confidentiality, integrity, availability. This deals with availability, which is in our scope as cybersecurity professionals to worry about. So if we notice and we're doing like some metric gathering, we're doing log analysis, we're looking at baseline behaviors, and we have a public web server farm or a public cloud resource that our consumers are accessing, and we notice increased loads on those resources, we have a couple options. As far as an option on the network, we can place a load balancer in there, and that load balancer will distribute the network load, okay? And when we distribute that network load, we then make our resource availability much more efficient. So one server doesn't take on the entire load, okay? Now, when it comes to load balancers and how we configure them, there's always going to be some basics to it. So whether it's an on-prem load balancer that sits at a data center, or if it's in the cloud, an internal or outbound load balancer gateway, like something in Azure, where we sit that in front of our VNets in Azure, there's going to be a couple different ways we apply it. So we're going to have different algorithms that are set for our load balancer. It could be something like round robin, where we're not taking too much, how do I explain this? Round robin is just incoming transmission, go to server 1. Next incoming transmission, go to server 2. We're not gathering any metrics, okay? We're not basing it off the actual load. We're just saying a round robin algorithm. Okay, we could have something that's measured. So we could be polling our web servers and saying, hey, server 1's at 60% capacity, whatever that metric may be. If we're basing that off CPU load, memory, whatever the case may be, or actual outbound traffic, whatever the case may be, server 1's at 60%. So I'm setting up this load balancer to have a weighted algorithm that says, okay, I'm going to poll the servers, and if server 1's at 60%, server 2's at 30%, I'm going to send inbound transmissions over to server 2 because it's only at 30% load. And this doesn't always match as far as number of streams. Because technically, we could have something like this. Let me grab my pen real quick. Where we have a load coming into server 1 here, and that one data stream, whatever it may be, maybe it's doing a big download, could be taking up, I don't know, 200 megabits of bandwidth. Now, obviously, in today's modern age, we're scaling a lot of network traffic up. It could be even more than that. And then server 3 here could have 3 different TCP sessions on it. Now, again, this is just an example. We're dealing with hundreds of sessions, a lot more data that isn't as simple as 10, 15 megs, okay? And maybe each one of these loads is 5 megs. So if we did a round robin here, where we just send like this, maybe that's not the best solution for what we currently have. Maybe we want more weighted things. Maybe we want a weighted distribution where we are pulling these servers and our load balancer is smart enough to say, well, server 1's actually taken on way more of a load than server 3, even though it has 3 transmissions. So the 4th transmission, inbound transmission, I'm still going to send to server 3, okay? So that's how we do traffic management on our load balancer. Some more architecture here is the load balancer kind of does end up almost being like a reverse proxy as well, where we may have what's called a virtual IP here. So our web server farms may be like this subnet here, /24, this is .3, this is .4, and maybe this sits in the cloud. So maybe this is part of a VNet subnet here. So maybe this is like a Azure VNet 1, and this is our subnet here. It's the 10.0.0.0/24 subnet. Maybe our load balancer here is going to be part of that subnet. It's going to have this virtual IP. Maybe it's like .1, which in Azure VNet that wouldn't be accurate. So I'm going to change that. Let's just say it's .10, okay? And then it maybe have the public IP there. So then we have a public IP here. And when we have users attempting to talk to our web servers here, they're actually going to connect here, okay? So now we start thinking about second order effects. This almost becomes like our proxy here, and our users are connecting to this public IP. So now when it comes to like things like DNS, we have to keep that in mind that we may be dealing with the load balancer's IP rather than the web servers here, okay? Hit this slide real quick. Scalability and flexibility. So this facilitates scaling of applications and services by seamlessly adding or removing servers without disrupting the user experience. Okay, cool. Now let's move on. So how that relates to cybersecurity, remember, cybersecurity is not just putting in security measures, it's also worried about availability, okay? So as a cybersecurity professionals, as we do our scans, and we may notice a server taking on an unnecessarily large, network load, then maybe we suggest that to like our network or our cloud or our systems engineers, okay? All right, IDS and IPS, so intrusion detection and intrusion prevention systems. So IDS and IPS, these are going to be other security solutions that do monitoring, detection, and also prevention for malicious traffic coming across our network. Now, IDS and IPS, we have multiple different flavors of it. This could be doing network intrusion detection prevention. It could be part of a antivirus or some sort of host-based solution that's doing IDS and IPS on a single host. We also have a wireless intrusion detection prevention system as well that could be done from like our wireless LAN controller on-prem. It could be done from like a cloud-based controller that's actually scanning and looking for like rogue access points, things like that. It's not necessarily, standard, but it could be. But essentially to break them down, what they do, any IDS or IPS system, IDS is going to detect, so it's going to be a detective control. So if we want to get some sort of alerting, so let's say we have an IDS, I don't know why, I have the wrong image up here. I wonder why. I'll have to fix that on the break, but anyways, we'll move on. But let's imagine this is an IDS. So I'm going to draw this different, okay? Let's say this is an IDS system. So we deploy that IDS system, and the purpose will be to have a detective control, something to monitor network traffic and look for something suspicious. So let's say we work in the finance industry, or let's say we have credit card transactions coming across our network. So what compliance do we have to be aware of? So let's say this little organization here is a data processor for credit card transactions. For credit card, I need to write better. I always get comments about that. For credit card transactions. So now what compliance do we worried about here? We're worried about PCI DSS compliance. So we have to make sure that credit card numbers, personal information about that credit card is not being exfiltrated from our network. So we have to make sure that CVV information is not being exfiltrated. So one of our solutions to that is maybe an IDS/IPS system. So what we do is that we install an IDS solution. Now, typically this could be like part of your firewall. This could even be part of your router. Some vendors like Ubiquiti, its router also has IDS. So we implement some sort of IDS solution. Typically it's part of some sort of like multi-suite thing, or it's part of our firewall, it's part of our SIEM, some sort of solution. We implement the IDS plugin, whatever the case may be, and we put a large learning model on there. So we say, hey, IDS solution, I want you to monitor network traffic and get us a baseline. Get us a baseline of what normal looks like, okay? And once you've established that baseline, which involves ingesting a lot of data into you, whatever AI-enabled plugin you may have, and once you get that baseline, if you see any deviations, like unique port numbers being used to exfiltrate data on a TCP session, or maybe you're doing deep packet inspection and you see CVV information, we want you to alert us of that. So now our IDS solution, not only are we activating it to create a baseline, to look for baseline deviations, and maybe look for things that we have to be in compliance with, but now we have to set up alerting. So in that IDS system, we have to set up our alerting. How do we want to do it, and how do we rate the alerts? And what I mean by that is, one, we have to define false positives, true positives. So we have to define what is a potential malicious event. And then two, we have to say, what kind of severity score do we want to give this? Now, this is kind of up to the organization. So we can say, hey, if our IDS solution detects a SEV1, which means we see CVV data being exfiltrated on a weird port at a weird time, a SEV1, we want that IDS to email, hit our Slack channel, and also send a phone call to the on-call person, whoever that may be, okay? So when you implement IDS, these are all the things you have to think of. Don't just implement it, have it do some basics things. Like, when you implement IDS, sometimes it'll be like, oh, subscribe to our real-time threat solution. We have this large document of all these signatures we're going to look at. And it's just like basic. That works, but maybe you want to be a little bit more hands-on in the administration of it. Set up alerting properly. Make sure you're looking at those flags, scanning flags, okay? So that's what IDS does. Now IPS, guess what? It's going to do all those same things for us, but instead of it just being a detective solution, it's also going to be a preventative solution. So IPS will also allow us to block malicious traffic, okay? So IPS will be able to do all this, look at baseline deviations, and then we can configure it to do blocking. So we may be able to say, hey, if you see a SEV1, block that data for now and send us an alert so we can inspect it to make sure we're not messing up anything that may be critical, that may be not malicious, okay? So those are our IDS and IPS solutions. Now remember, I went over kind of network-based here. Part of your like EDR, XDR software suites that can be installed on hosts, your antivirus software solutions can also have this functionality. And we may not call it you're installing a HIDS. You're installing an anti-malware, antivirus software solution, and you're paying maybe an extra monthly subscription, some extra licensing, whatever the case may be, to add in IDS, IPS solutions, okay? That's typically how you see it. Okay, moving on. Now let's go over a web application firewall. So when it comes to firewalls, we have a lot of different types, different placements, different solutions for our firewalls. So with a web application firewall, this is going to be specific to monitoring web traffic. And we say web, we mean hypertext transfer protocol. So when you see on your exam web application firewall, you should automatically thinking, if I'm deploying a WAF, that means I have some web-based public resources, whether that be employee portals, our front-facing consumer website, whatever the case may be. If I'm deploying a WAF for that, I'm protecting against web-based attacks, web application attacks, okay? That's what a WAF does. A WAF will inspect your HTTP traffic and filter it deny malicious incoming HTTP traffic, and it's based on that. So we think about web-based attacks, in SQL injection, our injection attacks, cross-site scripting, API attacks, because REST APIs, they come over what? HTTP, right? That's what the WAF is protecting us against, okay? Malicious HTTP-based attacks, like injection attacks, cross-site scripting, API-based attacks, okay? What it will do, essentially, is if it sees any of those attacks coming inbound, it'll send back an error code to that attacker from that source IP, from wherever the source may be. Now, web application firewall, you typically see this being deployed in the cloud, right? A lot of times this is deployed in the cloud. When we have those cloud server farms, I like to call them, really just cloud-based web resources that our employees are accessing, consumers may be accessing, we may want to put a web application firewall. And every cloud provider has a different way of doing this. So don't get too caught up if you're like an AWS or Azure guy or gal, and you're like, well, in Azure, I use network security gateways and ASGs. Essentially, that could be a web application firewall, but then they also have their own web application firewalls that are dedicated to it, okay? And the scope of how we're learning it, CompTIA, and it's just a non-proprietary certification. Just know WAF equals HTTP protection, which means protecting against web application attacks like SQL injection, cross-site scripting. Now, if you're ever curious of what kind of web application attacks are the most common, like let's say you guys are working, you're a cybersecurity consultant, and you have a couple customers that have WordPress sites, right? Small businesses with WordPress sites that are growing and they want to be protected. And so you know about all these services because you came to TripleTech's class. You're like, do we need a web application firewall? Do we need a firewall on this? If you want to look at the most common attacks, how to protect them, there's a website for that. It's called OWASP, which will show you the top 10 web application security risks. I know it's a little old, but they update this. And this is a common threat feed that cybersecurity professionals that are protecting web services can look at. Okay, moving on. I feel like I'm going a little slow. All right, network access control. So NAC solutions, and I say that as a kind of an umbrella term, network access control solutions are pretty simple when it comes to just the definition. We're protecting who has access to our internal network. Meaning, when I have open ports in my reception area, if someone comes and plugs their Kali Linux Raspberry Pi box to do some attacks on us, my NAC solution prevents that. My network access control solution will prevent that. It controls who has access to the network and what they're authorized to have access to. So when it comes to like AAA, authentication and authorization, NAC can do both. So what kind of NAC technologies are out there? At its simplest form, on our switches, we can do something like port security, where we're filtering based off the number of MAC addresses or what MAC addresses can have access to that physical switch port. In our wireless realm, we have WPA 2 and 3 enterprise solutions, which do work with a Radius and AAA server to give a username, password, or maybe some token-based authentication to our wireless network, right? So the AP, broadcast an SSID, you try to connect to it, it prompts you for username and password. That means there's a WPA 2 or 3 enterprise solution, and behind that is some sort of network access control architecture, dealing with the AAA server and Radius as that protocol to send those authentication, authorization, and accounting messages between wireless access point, switch, AAA server, and maybe a wireless LAN controller, depending how we have it architectured. Another network access control solution is something called 802.1x, which we may use in conjunction with like a Cisco ICE server, Identity Services Engine server, that will say, hey, we're going to need that workstation that you're going to add to the domain. We need to put some licensing on there, a certificate on there, and when it connects, when it hooks up to the switch, in that request to get IP addressing and getting access to the domain, we're going to make sure that that computer has authorization to get access to our internal enterprise. So that's that NAC appliance there. And maybe that NAC appliance uses another technology called TACX, which is another AAA protocol that we can deploy, okay? In the short form, NAC solutions enforce security policies controlling access to network resources based on user identity and device compliance status, okay? I just quickly went through all the different types of NAC solution protocols we could have. Okay, VPN. how do I talk about VPNs without deep diving? So VPNs, when it comes to enterprise. Now, I remember CompTIA certs, we put ourselves in the shoes of an enterprise cybersecurity engineer, right? So you may use VPNs to go watch movies in Canada, get Canada Netflix, Europe Netflix. When it comes to our enterprise, though, VPNs originally were there for connecting remote sites to each other and then coupling that with some sort of encryption to give confidentiality to our data in transit over the untrusted network, which was an ISP. So VPNs, as their original solution, were meant, let me bring my pen here, that if we had our hub, our HQ here with our data center, which may contain like all of our SharePoint portals, like enterprise services, and this was located in New York, and we had a outsite or an office, whatever the case may be, in Phoenix, and we needed direct access to these internal enterprise resources that weren't public facing, a VPN was our solution. So we create that direct connection to that to that HQ site, okay? Now, VPNs have evolved since then. It's now a consumer solution as well to protect your information. VPNs also add encryption on top of that. They layer encryption. There's many types of different encryption we can use in a VPN. Site to site, we typically have something like IPsec, Internet Key Exchange version 1, version 2. We have TLS VPNs that are typically used for like remote workers. My personal favorite, WireGuard VPN. I use WireGuard between my offices, my home, my remote workforce, and that has their own encrypted solution to protect their data in transit. When you see this between router, firewall, distant sites, we call that a site-to-site VPN. I don't know why I put VPP there, but VPN. When we have a remote workforce, so that's when we have, let's say, a user here, and that's connected to their home network, and that single computer here needs access to our internal enterprise. We call that a remote access VPN. And that's going to be client-based, where it's just an application on the actual client's computer that gives us access to our internal enterprise. Then beyond that, we have two ways of employing the VPN when it comes to network traffic. We have something called a full tunnel configuration and a split tunnel configuration. To put it simply, a full tunnel, all network traffic, no matter where the destination is going through that VPN connection. With a split tunnel, we will have our regular internet connection coming out our network interface card. So if you're on Wi-Fi, that's your wireless NIC, which reaches out to your ISP. Then you have your VPN interface and tunnel configuration connected to the enterprise. And depending on where your traffic is destined to, for example, split tunnel, internet traffic, will go out your NIC. Enterprise traffic that's destined to our enterprise servers here, which just means that your layer 3 header, the destination IP header, is headed to an IP address within this subnet here at our HQ. That's going to go over the VPN tunnel, okay? So that's everything I think we should talk about when it comes to VPNs, all right? That's the down and dirty. Ever since I switched over to MacBook, this EpicPen software sucks. So sorry if it freezes sometimes. Okay, DNSSEC. So domain name system, domain name services, domain name server, right? DNS. What does it do? DNS translates host names to IP addressing. What we need for the internet to work. When I type in trepatech.com, right, that actually equals a public IP address that I'm actually building for my packet, right? My packet doesn't take a name, it takes a destination IP. So to get that destination IP, I need DNS to get me it. So when I type in trepatech.com in my URL, before I can even go to that destination, I gotta get the IP address of trepatech.com, that domain name, that essentially web server, right? That process of doing a DNS request inherently is unsecure, meaning that we could have a DNS poisoning attack, an inline attack, where we get sent back bad information. Our recursive server could get sent back bad information. DNS inherently doesn't have any authentication involved, doesn't have any security. DNSSEC, the security extensions, in conjunction with PKI, allows us to have authentication of our DNS responses. So this DNSSEC protocol adds security to DNS by giving it authentication, okay? It verifies that the received DNS response is authentic, preventing DNS spoofing attacks. That's what DNSSEC does. Be very careful though. This does not give encryption inherently. It doesn't give confidentiality. It's not going to encrypt those DNS requests over that untrusted ISP connection. It's going to give us authentication, okay? It's going to allow us to verify, yes, this DNS response is from a good authoritative or root server or name server or TLD server, and I know I can trust this response, this A record that it's delivering to me, okay? All right, now we'll move on to firewalls. So we have UTM and next generation firewalls. So with UTM appliance, don't get too caught up on the actual acronym here. This essentially is saying I am deploying a Palo Alto firewall, and instead of it just inspecting layer 3, layer 4, destination, port, protocol, source, destination, IP address, whatever, it's also going to do IDS. It's also going to do data loss prevention. I'm also going to enable a LLM on there to create baseline behavior and then add in an additional DLP solution on top of that. That's all it's saying. UTM is just saying this is an all-in-one appliance that can give us multiple different security mechanisms, okay? That's a UTM. My Ubiquity router could be considered UTM because not only can it do routing, it's a VPN server. I have my WireGuard VPN server. It's a VPN client. It can do IDS. I can do firewall statements on it. That's a UTM solution, okay? But when I go buy it, they just call it the Dream Machine Pro, and I call it a router, right? So, but it can be labeled a UTM because of all the additional security functions it has. Now, a next generation firewall is something specific to this exam. A next generation firewall is a dedicated firewall appliance that has enhanced capabilities, like deep packet inspection, like instead of just filtering inbound and outbound based on IP and port and protocol, it can go deeper in the OSI model. It can actually look at your application. It can do a deep packet inspection, break down that TLS session if we enable TLS inspection, and say, hey, whoa, I want to be very granular in what I'm actually filtering. I can allow you to go to Facebook, or excuse me, messenger.facebook.com, but I'm going to block the URL request to facebook.com. So it can be that deep. It can actually look at the applications, okay? That's specifically a next generation firewall. Now notice what I said here. Remember that web-based traffic, remember it's end-to-end secured. So when I start a web session to this web server here, from end to end, it's protected by TLS. But our next generation firewall does deep packet inspection. But I have end-to-end encryption. So how does it do that? If you want your next generation firewall to be able to inspect your users' end-to-end traffic between client and web server that's TLS protected, you will need to enable what's called TLS inspection, where essentially that firewall gets its own certificate, it becomes part of the PKI, it does, it becomes part of that TLS transmission, okay? Now let me show you what I'm talking about here. So if I open up Wireshark, give it a second, okay? And I want to inspect my wireless NIC, okay? So let me inspect it. Do you see it's coming at you 100 miles an hour? Let me just pause it here. So this is a web session. So this is an HTTP session, right? HTTP over TLS, but I cannot see any of the data coming across there. I just won't be able to see it. It's encrypted application data. So if even at my host, my Wireshark application, directly inspecting the traffic leaving my NIC can't see inside this, your firewall can't either, unless it's almost acting like a proxy. Taking that TLS session, decrypting it, looking at it, re-encrypting it, and sending it on its way to the web server, okay? So just think about that, all right? I don't know if that'll be on the exam, but it could be. You know, this is an advanced cybersecurity cert, so we should know these things. All right, a router. Pretty basic, guys. A router routes layer 3 based traffic to its destination, or an internet gateway. Additional things you have to worry about as far as a cybersecurity professional. So at a router, you can also put security controls and measures. You can do ACLs. You can do, like I already said, you know, my Ubiquity router is a UTM. So it's already doing a lot of these advanced features. But its main purpose is to do traffic routing. And if it's not doing that main purpose well, don't worry about the additional things you can do, okay? If this is your core router, your core transport router, like your campus network, you have a big campus network, your engineering, make sure that the focus is getting packets to its destination, okay? Additional technologies your internet gateway can do is things like network address translation and port address translation. Okay, let's go over these proxies here. So a proxy, let's take a step back actually. We have two types of proxies, forward and reverse proxy. So what a proxy does at its base function is essentially it hides something for you. So it either is going to hide your user's IP address when they go talk to the internet, or it's going to hide your web server farm's IP address. So look at our images here. A forward proxy, when all of our users are reaching out to the internet, it touches this proxy first. We might be doing some packet inspection there as well. And then it's going to pretty much translate your user's IPs to something else, like a public IP, and then send out to the internet. That's its basic architecture. So you may be telling me, well, what's the difference between that and a router that does PAT? That's just what a forward proxy does, and that's maybe why it's not as popular, or why it's just really sometimes they call it a proxy, but just doing packet inspection, which our next generation firewalls do too. Not just like you may be saying, well, what's the point of it? Just different engineering, different strokes, right? Okay, reverse proxy though is very, very common. I don't see the forward proxy a lot. As being a network consultant, I see like F5 solutions, which I technically were proxies, right? But they do load balancing, they do packet inspection. You call it a forward proxy, whatever. I see that a lot. But when network consulting, you go to the data center, you do the cloud consulting. Reverse proxies are very common. Even if they don't call it a reverse proxy, our load balancers have this function where essentially that reverse proxy will have a public IP here, it'll have its virtual IP here, and then it's talking to all your web server farms. So when a user connects to these web servers, they're actually connecting to this public-facing IP here, okay? It's protection method. Damn, I kind of already went over this. Okay, let's talk about DDoS, distributed. Ooh, I've been talking for a while. Let's actually go ahead and take 10. I got 6:50 p.m. East Coast time. We'll come back at 7 p.m. I'll put the timer up, and I'll go a little bit quicker so we can get through domain 1, okay, guys? Okay, let's go ahead and get started again. So where did we leave off? Yeah, DDoS. So now going over distributed denial of service protection. So to find out how we protect this, let's first go over what DDoS is. So distributed denial of service, no matter if it's a SYN flood attack, if it's an API-based attack, it is a botnet that is sending or overloading some sort of resource or service on a device, whether that be web server, a firewall, a router, or internet gateway. That's what DDoS is in its simplest form. A bunch of bots being controlled by a command and control server to create a botnet to flood a resource or service to deny it being available to legit requests. So DDoS protection mechanisms are designed to safeguard networks and services from denial of service attacks that can render resources unavailable. So there are some simple things we can do. So the attack mitigation, we have like API rate limiting, we have high availability architecture solutions. We could have next generation firewalls or web application firewalls. And a common solution if someone's trying to do a DDoS attack from a certain region, we have like IP blacklisting that we can integrate into our firewalls. We can just have, again, those architecture solutions like redundancy. So spreading out our web servers and having the adaptability to say, hey, we see increased load here. Let's move these network requests to our east region or our west region, kind of thinking more cloud-based, okay? Okay, routers, we already talked about that. Again, I'm going off the exam objectives. So internet gateway and routers were on the exam objectives twice. So we'll move on. Okay, so there is a quiz, guys, that on our Academy site that we can go over. Let me just bring something up here and we'll go over this quiz real quick. Okay, so question 1. For an organization implementing a BYOD policy, which is a bring your own device policy, which service is essential to manage network access based on device compliance? So essentially what we're saying here is that our organization lets people bring in their own computers, their own devices, whatever that mobile, laptop, probably not desktops. I don't want someone bringing their own desktop, but they're bringing in their own devices. What technology or what can we implement? What security solution can we implement to make sure that this is protected? That is going to be, yes, B, network access control. And remember, you guys can do this as well, while you have lifetime access to all this shit. Okay, question 2. Which network service is most effective in evenly distributing incoming network traffic across multiple servers? So that's, again, distributing our network traffic. Yes, that is going to be B. When I built these guys, these quizzes, this is when I first started integrating like AI to build questions and me reviewing them. And for some reason, they made a lot of them B for the answer in these quizzes. So don't think the real test is going to be like that. These are just things that we made, okay? I hand jammed. And part of our learning management solution is we integrate GPT. And this was like GPT 3.5. And for some reason, they just made all the answers B. Anyways, so if you see a lot of B answers as you go through this, just... anyways, which service is specifically designed to analyze traffic patterns and detect potential threats based on network behavior? That's going to be our IDS solutions, right? So that is A. Good job. The questions on the CASP exam, no, we sign an NDA when we take it, so I can't talk about what's on the exam, but they're generally harder as well. That's just a nice little check on learning. Question 4. What is the primary purpose of implementing DNSSEC at the DNS layer? So what does DNSSEC do for us? We're going to go with C here, to ensure data confidentiality and integrity in DNS. Question 5. Which service effectively allows a company to hide its internal IP addresses from external networks for security purposes? So what allows us to hide it? It's not going to be a firewall could do it, but we're talking the exact service here, right? Specific technology, that's going to be NAT, right? So yes, good job, guys. C, Network Address Translation Gateway. Now, I do like how vague this is because NAT can be done on our on-prem routers. There's also NAT actual appliances. Like in Azure, a NAT gateway is an actual resource you can configure and you'll get billed on. Just called NAT gateway, okay? So I do like the way this actually is written. If you have never been in the cloud, you may be like, NAT gateway, you mean my router? But anyways. Question 6. Which of the following services would be most effective in protecting against SQL injection and cross-site scripting attacks? Those are our web-based attacks, right? That's our HTTP-based attacks. We're going to go with WAF, a web application firewall. Question 7. In the context of DDoS attack mitigation, which of the following is the most effective for protecting the availability of network services? Okay, so with the availability of network services, let's see here. So again, we're not talking about just like exactly stopping the DDoS attack. We're saying what will keep our availability online, right? So we're going to go with distributed denial of service protection. There's our explanation. Then the last question here, we're trying to get that 100%. Which of the following is primarily used to ensure secure, encrypted connections over the internet for remote users? That is going to be our VPN solutions, right? Now, what type of VPN? This is going to be a remote access VPN for remote users. Typically, this is like TLS encryption as well, okay? So, VPN. All right, let's go. We got 100%. Now, let's get back to our slide decks here. Now, we're going to keep going over Domain 1 objectives. Let me present this. All righty. Okay, let's go ahead and get back into it. All right, so now we're going to be going over this second slide right here, or these objectives, these sub-objectives, okay? So mail security, API gateways, traffic mirroring, and sensors. You know, they call SIM sensors, but anyways, remember this came out in 2021. So not that all these technologies are still around, but sometimes I wouldn't call a SIM solution a sensor, but that's what they say for this CASP exam. Again, not talking shit about CompTIA. We're a CompTIA authorized training partner. You know, they do great things. Okay, mail security. So mail security solutions. What we're just talking about here is whatever, if it's Office 365, up in the cloud, if you have an on-prem Exchange server, if you still have one of those, I feel bad for your system admins, but it's still around. Other mail services, maybe you're doing like an open source solution. We need to implement mail security. Down to the basics, this is protecting your DNS. So you're going to have things like DMARC and SPF that protect your mail gateways from spam, from blacklisted domains, reaching your users. Now, why is this important? Because a lot of times exploitation, attacks, what do they come from? They come from human error. And what do we do to exploit human error? Social engineering. What's our biggest social engineering attack? A phishing attack. Why do we do our cybersecurity awareness every year? Because of things like social engineering. So one way we can mitigate that is by implementing mail security. We can have spam gateways, SPF records, DMARC records in our DNS. Because remember, we have MX records in DNS, which point to our mail gateways, okay? We also want to do data loss prevention. We want to integrate things like PKI into our enterprise mail solution so we can put digital signatures on our email. We can put encryption on our emails when we're sending sensitive topics so we don't have those data breaches, okay? So API and XML gateways. So to understand an API gateway, we kind of have to understand what an API is. Now, as a senior cybersecurity engineer, if you can't describe what an API is at a low level, there's something wrong there, okay? So I will try to break this down Barnett style because I understand that maybe as traditional cybersecurity engineers, we don't understand exactly what an API does if we've never done like development. But essentially, an API opens up, if we look at like our traditional web architecture, an API in the back end of our web server allows us to interact with our databases, okay? So APIs allow us to interact with different services and databases in our web architectures. In our non-traditional web architectures, where we have microservices, APIs are the way we interact with those microservices. So if we're making an API call, we're going to have some sort of API built on the back end that allows us to perform that call, okay? Because of that, sometimes this is open to the public as well. It's not always just developer access. Anybody can get access to this API that's open, and we can do API calls to it from my workstation. So because of that, we may want to put these APIs behind some sort of gateway that is going to monitor the API request. Maybe we're going to put in some authentication there. So maybe we say, hey, if you want access to this API, you need developer access, which means you need an account on our enterprise. So it's not open to the public, okay? So API gateways give us that integrity, the authenticity, and then allows us to monitor overall API calls. And then maybe all that monitoring we can ingest into some sort of log aggregation solution like a SIEM or SIEM, okay? Maybe that API gateway can do something more advanced. Maybe it can start building baseline behaviors and then alerting us when things deviate from that baseline behavior. Okay, moving on. Traffic mirroring and analysis. So when we talk about traffic mirroring on our local area networks, on our campus networks, this is like a layer 2 solution when we talk about span. And what this allows us to do is on our switch, we can configure a port for one of our users, and we can mirror that traffic. Meaning we're going to duplicate all the traffic coming in on this switch, send it over this port over here, and then this admin computer will be running Wireshark and ingesting all that duplicated transmissions from this user over here, and now we can perform packet inspection. So this allows us to see, like, if one of our users, like, we have a really unique error where they can ping a web server, but they can't get to HTTPS. It's not our ACLs, it's not DNS. There's something weird going on. We need to actually look at the deep layer inspection, right, from the source. This is one of our solutions here, span. Now, span can be configured on a single switch, and then you have to be connected to that switch to actually get that mirrored traffic. Or you could have remote span, where, let me draw this out, where we have another switch over here, and that's where our admin computer is. But we want to capture traffic on this user here. So we configure our span on this switch to say, hey, send that duplicated traffic over the wire to this switch here. Maybe we're sitting off-prem. Maybe we're at our house, we're connected to our home Wi-Fi, and we still need to duplicate that data. We have something called ER span, where in a GRE tunnel, we can actually send that duplicated data over the internet into our admin workstation here, okay? So a lot of different ways we can do traffic mirroring when it comes to like our enterprise and on our switches. Okay, network taps and port mirroring. Network taps and port mirroring are tools for monitoring network traffic, providing a way to access data flowing across. So again, just what I described, okay? Now, network tap could be something a little bit more specific. Like I could take, it's like something you can purchase off Amazon where you kind of put it as a man in the middle, right? Computer, network tap, and then switch, and then have the user do whatever, go on its regular web browsing, take that network tap out, plug it into your admin computer, it'll create a PCAP file, upload that PCAP file to Wireshark, boom, there you go, okay? That's a network tap. But when it comes to port mirroring, we're talking about span, what I just described. Span, RSpan, and ERSpan, okay? When I say PCAP file too, guys, that's what Wireshark creates. Like, if I do like a TCP dump on a Linux machine, and I export that to a file, it'll be a .pcap file. And that's what I upload to Wireshark to actually do like packet inspection, okay? So if I open up Wireshark again, just to show you this, and I swear I'll try to be more on track. I just, I feel like it's important. If I go open, so you see, I have this multicast sparse mode PCAP that I did, and then I have this recent capture results from my Linux class I just did. So this is from a Linux workstation that I did like a week ago. I just did a TCP dump on its NIC port, and that's a way I can look at my users, right? So imagine I did this using span. This is kind of like the flow of it, okay? And then we can see what this user's going on. But it's, they get saved as .pcap files. All right. So virtual private cloud. So VPC was originally like when AWS was coming up, guys, and we had to do network segmentation on our cloud resources. We called it a VPC. Azure calls this a VNet. And this is just a way of subnetting out in the cloud our resources, all right? We have different things we can do with our VPCs. We can do like Route 53 in AWS. We can do VPC peering connections where we may have a resource in like AWS East and AWS West, and we do a VPC peering connection, and all the resources that we put in our virtual private cloud subnet will have a direct connection to each other, okay? Rather than going out to the internet and coming in, they'll use like AWS backplane. In Azure, that's what I'm more used to. We call that a VNet, is the same thing as a VPC, which gives us that network segmentation in the cloud. And we can do VNet peering as well, where we say, hey, this resource in Azure West under VNet 1 is going to have a peer to VNet 2 in Azure East, and those VMs, let's say those are the resources in the cloud, can actually directly talk to each other. So if you want to see an example of this, let me open up my Azure portal, okay? Opening it up on a different web browser, hold on. Just so you guys don't see my password and stuff. All right, so my Azure portal here. Let's say, let's go build a VNet here, a virtual network, okay? This is a VPC as well. They just call it a VNet in Azure. I put it on our subscription. I'll create a new resource group for it. New RG for CASP. I'll give it a name. Let's just say VNet 1 in the West region. And I'll put it in the actual West region. Okay, next. I have all these different options I can do, so I can add all this extra security to any resource I put in this VNet. But I'm not going to do that. And then I have this default subnet here, okay? So you see I have this /16, but I could add more subnets if I wanted to. So, you know, I could add more subnets here, but I'm not going to. I'm just going to leave it at default, okay? Hit next, tags, and we create that virtual network. Now, if I want to go, we'll just do, virtual machine. Let's say I want to go build a virtual machine in here. Create Azure Virtual Machine. I can click that VNet that hasn't been deployed yet. Sorry. Log in here. That virtual network's probably not built yet. Yeah, still deploying. Let me see my notifications here. See, trying to go too fast. That's okay. But essentially what I just showed you, that VNet that I built, we could place that virtual machine inside of it. And all that extra encryption I built in that VNet will be inherently part of that virtual machine. Now, we can do so many other things to that VNet. We can put firewall rules in that VNet. And now all the resources in that VNet will also get those firewall rules, okay? I should have waited till it got finished deploying. But now it's just like, oh, just the concept of it. We'll come back to that maybe. Okay. SIME. And this is an important one. So, like, if we went on Indeed right now and looked at all these cybersecurity jobs, SIME, more specifically like Splunk, maybe Azure Sentinel, there's going to be a skill and a tool that they want you to know about, okay? SIME at its base is a log aggregation device that then allows you to index all that big data that it ingested, to scrum through that data, to monitor that data, to analyze all the data that it's ingesting, to set up real-time alerts, to do threat detection, and an old one appliance to also do response, okay? So SIME, as you can see in this little image, takes all these network resources, your servers, your firewalls, any of your security monitoring solutions, routers, switches, workstations, aggregates all their log data, even real-time events as well, into a single appliance we call SIME appliance, and then it allows you, the admin, to go into that SIME appliance and start creating dashboards that index off that real-time or that logged information. So it's a single pane of glass, that's the marketing term, that allows you to get view all the information happening in your network, okay? Now, a SIEM solution that's paid for enterprise that dominates is something called Splunk. Splunk does give out free training. So if you want actual SIM training, you can use Splunk. They have some free tiers. There's other free SIEM solutions, like I'll show you, that I've deployed and messed with here called, I don't know, Wazza. It's completely free, open source. You can go buy an old desktop with enough, from Amazon, a used one with enough RAM, compute resources, just maybe on like older versions. You can deploy that at your home and start ingesting logs from your home and start getting used to a SIEM appliance. It's also an extended detection response solution, which we haven't gone over yet. But you can see all the dashboards on there. If I wasn't streaming this on YouTube, so after I cut off the YouTube stream, I'll show you a little bit of SIEM solutions in my Ubiquity router. They kind of have a little bit of that going on as well. Okay? Let me see if that virtual network got created. Sorry, I'm all ADHD everywhere. I didn't get an error. I wonder why it just taken so long. Maybe I didn't hit finish or something. Anyways, moving on. But that's what a SIEM is. Now for the exam, remember a SIEM is a log aggregation, okay? Log aggregation. Okay, kind of a combination slide here, going over two technologies, FIM, file integrity monitoring. So FIM, what that's going to do is it's going to log and alert you on file changes. Now you may be saying, well, what if we have a working document and we have a FIM solution on a server and there's a working document we're saving on that server like a domain controller? Is it going to alert us every time it changes? Well, yeah, if that's how you configure it, right? But what FIM attempts to do is critical files like in your Linux devices. So like your Linux servers is all directories and files, right? If a critical file like the host file, the dhcp.config file gets changed without you knowing about it, without prior authorization, it'll alert you. So that's what FIM does, okay? It alerts you. Let's say you're doing some threat hunting and you make a file called passwords.txt. And you're like, we're going to see who tries to access this. We're going to put it in the accounting shared drive. And you see someone from sales trying to access passwords.txt. You set up FIM on that file, monitoring that file specifically, and it goes and alerts you. That's kind of also describing a honey file, but anyways. Okay, SNMP. SNMP is a simple network management protocol that allows us to monitor network devices. And typically with SNMP, it's a server to agent architecture, which is a little different than our traditional client to server architectures. So with SNMP, we have the server, let's say like a SolarWinds server, that SNMP manager, the NMS software, that's going to pull our SNMP agents for information. So the actual start of that transmission starts from the server, right? Server reaching out to the agents. Well, if we want our agents to actually send critical updates to our server without us creating that SNMP pull, we have SNMP traps. So SNMP traps are done from the actual SNMP agent, okay? Which will give us what's called what I wrote down there, an enhanced security posture. Remember, for our defense in depth approach. So we're always trying to achieve, that it's that onion, that layered approach to cybersecurity. Okay, some other technologies that can help us enhance our visibility and prevent data exfiltration. So NetFlow. NetFlow is a technology that will allow us to see our top talkers, the bandwidth usage in our network, which can give us an insight into where our users are going to. That could help us adjust our quality of service policies. It could also give us visibility to our top talkers, which means, oh, hey, we see this user is downloading so much. What are they doing? Pirating? Are they torrenting? NetFlow can do that analysis for us. Data loss prevention. That is whether we deploy it on a host, on the network, part of our antivirus solution, part of our next generation firewall. DLP in its base stops data exfiltration, stops our sensitive data from being exfiltrated. If we have to comply with the General Data Protection Regulation, EU customers, and we have GDPR data that we classify on our network, and we see it getting exfiltrated to a destination IP we don't recognize, DLP is supposed to stop that, okay? Whether that's host-based or on the network, okay? DLP can also stop us from plugging in external devices. So you see this little image down here, right? Well, someone was, there's a news story about, I forget what cyber attack did it. We could probably look it up in the MITRE attack framework, where people were leaving like malicious USBs in parking lots of our corporations. They were plugging them in. Well, if you had some DLP protection on the host, you could potentially prevent that, right? Okay, antivirus and network security. So we'll start with antivirus. So antivirus software solutions typically get installed on the host, and they can do a lot of different things. Again, at its base, antivirus is just meant to scan your device, maybe signature-based scanning or heuristic-based scanning, which I'll define here in a second. And if it sees a virus, it's going to quarantine it, sandbox it, or get rid of that virus. Now, virus could be, we have all over different categories for it. Ransomware, Trojans, worms, just anything malicious. Any malicious software, okay? So it gives us malware protection, gives us real-time scanning. Now, I said there's a couple different ways that antivirus solutions do their scanning. So we have signature-based and heuristics-based scanning. So with signature-based scanning, that is we're going to have just imagine a document. Now, it's not as simple as this, but a document full of hashes. And those hashes correlate to well-known viruses that we logged in the past. Now, I say we, imagine McAfee. I was like, from all the 30 years, 20 years we've been doing antivirus, we have all these different signatures of well-known viruses, okay? And that's signature-based scanning. We compare what's on the computer to this database we have as signatures, and if anything correlates or matches that signature, we're going to alert you. We may sandbox it, quarantine it, or get rid of it, depending on how the antivirus solution is configured. Now, this could be a standalone solution, just installed on your computer, or we could have a client-server architecture of antivirus, where we have a centralized McAfee antivirus server that is taking most of the compute away from the user. Because, when you install antivirus, it does take a lot of compute resources, and it slows you down. Okay? So that's like agent-based versus agentless-based solutions, which we'll talk about later. I also talk about heuristic-based scanning. So this is kind of like the machine learning before machine learning, or heuristics-based, where, well, I said that before it became just like every friggin' startup is saying they're AI-enabled and getting VC funding. What I mean by that is, not to deviate too much, heuristic-based scanning, instead of it being a well-known signature database, we're doing it based off the behavior. So with heuristics-based, we're saying, hey, at 2 a.m., we notice a spike in network traffic from this computer. What's going on here? We're going to alert you about that. That there's suspicious activity. That's heuristics-based scanning, okay? So kind of just analyzing the behavior. And if something deviates, then alerting or preventing that deviated pattern from happening. Oh, cool. We'll do our check on learning, then we'll go another 10-minute break because my voice is, I don't want it to go away. All right, let's go back to our lessons here. We're at domain 1.1.2. Let's take this domain quiz. Okay, so question 1. In the context of network security, what is the purpose of implementing file integrity monitoring? So what does file integrity monitoring do? That's what we're asking. So yeah, that's going to be B. To detect changes to critical system files and configurations. Question 2. What role does a virtual private cloud play in enhancing network security for cloud-based resources? So that's going to be A here, right? Yeah, good job, guys. It provides a segmented portion of public cloud isolated for private use. Yeah, that's like the book definition. As you see, though, like, you can put anything you want in a fucking VNet. It can still be open to the public unless you do the right configurations. But CASP book definition, right? Yeah. Okay. Question 3. What is the primary function of security information event management in a secure network architecture? D. Yes, good job. Remember, that's aggregate. You see log aggregation? Boom. SIM. People call it all different things. I've heard trainers call it different things. I call it SIM. To aggregate, analyze log data. There's an explanation. Question 4. Which of the following is a primary use case for employing traffic mirroring in network security strategy? So that's going to be B. Remember, traffic mirroring. We're duplicating the traffic on a specific port and then sending that duplicated traffic, which is essentially that .pcap file, which I showed you, so that we can do packet inspection. So to analyze traffic in real time for signs of malicious activity. Question 5. Which service would be most appropriate for an organization looking to monitor network performance and traffic patterns as part of its security operations? Network performance, that's the NetFlow technology, okay? Remember, NetFlow allows us to see what applications our users are going to, what common websites, and bandwidth, okay? That is NetFlow, A. Question 6. For an organization looking to enhance its ability to detect and respond to network security incidences, which of the following would be most effective? So to enhance its ability to detect. Okay, let's see. So on here, there's only really two options that make sense, SNMP traps and SIM or SIME. But SNMP, honestly, it wasn't even purpose built for cybersecurity. It was put for network monitoring. This is allowing us to respond to network security incidences, right? This security, that's what we're talking about here. So we're gonna go with SIM. Remember, that allows us to have these dashboards that allow us to look at the real-time events happening. Question 7, which service would be most beneficial for ensuring the security of API communications in a distributed application environment? Yep, good job. That's A, an API gateway. The only one that makes remotely any sense there, right? Dealing with APIs. Last question here. Which of the following services is most effective for monitoring and preventing unauthorized data exfiltration across a network? When you see stopping data exfiltration, guys, always DLP, right? Always data loss prevention. Kind of in the name. As long as you know that acronym, right, you kind of know it. So data loss prevention. All right, let's go. I'm going to do 10 minutes up here. Let's come back in 10, guys. You need to get my voice to break, and then we'll move on to the next section. All right, now let's go over domain 1.1.3. So we're going to go over all things segmentation. So all the different segmentation tools and technologies we have, whether that be on-prem in our traditional network or in the cloud. Okay, so segmentation. Just going over the basic definition is segmentation is going to separate our network resources, whatever that may be. So on-prem, we have traditional segmentation like using VLANs. We have segmentation in our CI/CD pipelines, where we have staging environments, production networks, where we, again, use the CI/CD pipeline with merge requests or pull requests. This gives us an enhanced security posture. We even have this in the cloud. We have micro-segmentation in the cloud. We have VNets and VPCs in the cloud, where we can apply different filtering rules on them. In traditional networking, we have north to south filtering typically, and that's where if you think about a network diagram on a campus network, where we have like our distro, core, access layer, our traffic is going up and down, north to south, and where that segmentation may lie is in that distro switch with those different switch virtual interfaces. With that network segmentation, we can also bring in our system engineering piece into it. Traditional environment, we may have domain controllers using Active Directory, and we may apply group policy to an OU, and that organizational unit may be tied to a subnet. Again, that subnet then on the network side is tied to a VLAN that may correlate to a department. So kind of bringing it all full together, business operations into our IT and IT security. In the cloud, we do something similar. Maybe we segment things like in Azure based off subscriptions, and then lower in the subscriptions, we have resource groups, and then VNets that contain all those resource groups, and we can have different compliance, different budgeting, and segmentation on those VNets. And we call that micro-segmentation and east to west filtering, because the way it lays out in the cloud is we have this multi-shared tenancy in the cloud. So we may be filtering resources that the actual data may live on the same server, but it may be segmented in our control, right? Our control plane. So with that being said, let's just go ahead and move on. So micro-segmentation. Did I miss something? No? Okay. Right into micro-segmentation? Okay. So micro-segmentation takes network segmentation further by isolating workloads from each other, even within the same data center, to provide granular security control. And kind of like I just described with the cloud, when I'm in the public cloud and I'm deploying VMs in the West region, that essentially equates to a cloud data center in a geographical area that all of us, we go created a VM in the US West region in Azure, we could have those payloads, our services, on the same exact racked server. But in our control plane, it doesn't look like that. We have different identity access management to it. We may be applying different filtering mechanisms on there, but that's what we call micro-segmentation. That's east to west filtering in the cloud. So we have filtering at the application level rather than just at the subnet level like we have with traditional segmentation where we use like VLANs, okay? And you kind of can see that with our micro-segmentation, it's east to west. So each resource here is filtered. Rather than north to south where I come up to like a default gateway, the default gateway may have like a VLAN tag, or really the switch would do the VLAN tag, and then the router does the routing, the inter VLAN routing there. Instead, it's east to west, right, between those appliances. Okay, and then our traditional networks, we have our VLANs, which segment things using a 4-byte header that gets inserted into that layer 2 frame. It's a 4-byte header that designates a VLAN number to it, and then that traffic is segmented in that VLAN across our layer 2 infrastructure up to our layer 3. So that gives us physical and logical segmentation, enhanced security and isolation. And again, on the system engineering side, we can build our organizational units based on a subnet, right? And apply group policy that way. Another segmentation technique that we can use when we have like a diverse ecosystem, different networks that we want, whole different enterprises we want separated, something like a jump box. Or maybe we don't want direct remote access to enterprise resources, we can put in a jump box there. That acts as a secure gateway for administrators where they connect to the jump box, and then from there, essentially, it's almost like pivoting, right? Like how an attacker would pivot. But then from the jump box, we then access our enterprise. You can see here in my example, we have our IT and our OT. Let me slow down a little bit before my voice goes away. So our data center would be our IT, our information technology. That's our traditional enterprising resources and things that we manage. Our industrial control systems, that would be OT, operational technology. You see a lot of times cybersecurity incidences in these big industrial companies. It's because of this reason right here. They don't separate their OT and IT, and it leads to vulnerabilities, right? Where that OT should be really segmented. So what we have here is we have an administrator that wants to remotely manage both the IT and OT, but instead of us allowing direct connections, we have a jump box that sits here almost like in a screened subnet or a DMZ between two firewalls. And instead of that remote manage it being direct, right, we don't want that. Instead, it's going to be to the jump box. And then from that jump box, we may allow protocols like RDP or Telnet into our old ICS legacy systems that don't support SSH. Yes, true, right? Because OT is built to last, right? These dams that were built in the 80s that are running on old computing systems, they probably didn't have SSH back then or even cared about cybersecurity. So that allows us, right, to use RDP, but not over the web. So we could say, hey, let me have an RDP session here, and we have that really on lockdown, right? Multi-factor authentication, whatever the case may be. Maybe it's a VNC connection to this jump box. And then from there, I get to the data center, okay? Now, the jump box could also be like where administratively you put a lot of your admin tools. So I've worked in enterprises before where I've had to set up my workstation. They say, here's a list of applications, go install them. These are all the admin tools you need. And I worked in enterprises that say, here's your workstation. If you need to get to Active Directory, Cisco IMC, the call manager, the firewall, ASDM, all these different admin tools. Here's the IP address. Remote into our jump box or our admin box. It's going to be a server where you can run all the tools from there. And then we do a privilege access management on there to see which admin was using which tool at which time in case there is an incident, right? So that also could be what a jump box does as well. Now to go over the points on the slide here, controlled access point helps with the audit and monitoring because we can see who made the connection to the jump box and from jump box to the data center. Kind of like could be part of a PAM solution, what we call it. This could be used for compliance reasons, right? Depending on the industry we're in, maybe there's some sort of compliance that says we cannot do those direct connections, okay? All right, and then a screened subnet, formerly known as a DMZ, that's where we have resources that maybe need to be internal facing to our enterprise and also external facing into that untrusted network towards the internet. So we put them what's called a screened subnet. Traditional network architecture, this firewall here would separate all three of these zones. Our inside zone, our outside zone with its different security trust levels, and then our another zone called it used to be called the DMZ, demilitarized zone, but now we call it a screened subnet. I do like, the name change is not bad, essentially just saying, here's a subnet, here's a part of our network that we're screening, that we're isolating because it's more risk adverse. Its attack vector, its attack surface is higher because it has to be external facing, okay? So because of that, we're gonna isolate resources that are external facing and our internal customers also need to reach in this screen subnet where we can enhance the monitoring, okay, and the auditing on this. So another controlled access point, right? And just to tell you, like, yeah, your Exchange servers, when they used to be like OWA before Office 365 was in the cloud, we used to put our Exchange maybe the OWA server, right, in that screen subnet that was kind of replicating off our Exchange server here. This web server, maybe that's hosting a portal that we have to reach from our houses, right? Remember, this is like traditional. I know things are hosted in the cloud now, so no comments about what in the cloud. I get it. But maybe this web server is also doing like an LDAP sync to our Active Directory server. It's not Azure Entra ID yet. And, you know, it needs to have ports opened internally, but also external facing. So we want to definitely put that in the screen subnet. Okay, data zones. Data zones are defined segments within a network specifically designed to handle data with varying levels of sensitivity and compliance requirements. This is its way of describing like MAC, mandatory access control, and need to know networks. You know, private sector, this is kind of just, maybe we have an industry compliance we have to comply with, so like healthcare, we have HIPAA, so we put all of our health patient information on a separate network that's only mandatory access. In the government, this one's easy. This is unclass, secret, and top secret networks. Those are different data zones, okay? So segmentation based on sensitivity. All right, jumping away from network architecture, system architecture, and jumping into development. So we talked about those CI/CD pipelines. When we're in a DevOps or we're actual software developers and we have DevSecOps and cybersecurity professionals working within our development pipeline, we're going to have staging environments. Without security, you still have this as well, these different staging environments. But from a security's perspective, this is what we want because we're worried about availability and we don't want changes going into production without first being tested in what's called a staging environment. So this could be deploying code to a sandbox. This could just be a developer at his computer testing out changes to our front-end website. Does it work in their local environment? Okay, cool. Let's send it to production. Let's do some A/B testing on it, right? But essentially, from the cybersecurity perspective, this is a safe testing environment where we can replicate the production environment to make sure it's safe to merge in to that development, or excuse me, to that production database, okay? So commonly what we see here, we're gonna make a code change. We clone the repo. We make a new branch called the development branch. We make our changes. We submit a pull request. Senior software engineer looks over it, says, code is good, it'll function. If we have a good DevSecOps pipeline, maybe we have a senior cybersecurity engineer look over the code change, see if there's any dependencies and libraries that may be vulnerable. No, blessed off on it. And now we merge that into production after some maybe additional testing, and that's our staging environments, okay? We have guest environments. So guest environments, this, as simple as put it, guest Wi-Fi, right? An environment where we give someone network access, but it's very, very limited. And maybe it's just, boom, you have access to the network that gives you access to a router out to the internet. But you don't have any access to our enterprise resources. So this is isolated access, limited network resources. It's a very, almost an air-gapped environment, but without being actually air-gapped, right? It's just a guest network with very limited or no access to internal network resources, maybe internet access. So imagine you're hosting, partners, potential acquisition. You have people coming in to your conference room to do a demo. They need access to the internet. Instead of just you're not going to make them full accounts and onboard them, so you give them guest access to your guest network. Okay, now in the vein of availability as far as it relates to cybersecurity. So we have something called availability zones. So availability zones are technically a cloud-based thing, but what we're saying here is that when we want high availability, we want data replication, high redundancy, and we're a cloud customer already. Maybe we deploy a resource in our East region, okay? But we have multiple data centers in that East region. So maybe we replicate it across those multiple cloud data centers. Because we could have an East region in Virginia and in South Carolina. And that still gives us that geographic diversity that we want. Where if something happens in Virginia, you would hope that in South Carolina, that data center will still be available. So the different availability zones are within that region. And those availability zones represent cloud data centers, okay? Policies security groups, so just saying that whether we're on-prem or in the cloud, we're still going to have security policies that get applied to different resources. Now, we talk about cloud, you really talk about our first security policy. I think of the first layer is our IAM, right? Identity Access Management. And you look at even zero trust network architecture, zero trust architecture, that's really where it starts too, right? Where principle of least privilege, never trust, always verify. So we want fine-tuned policy security groups that can be applied to our resources and our access management. Still in the cloud-based technologies here, we have different geographic regions that we may place our resources in. So we have the East and West region here, where we have different availability zones within those regions, and maybe we can deploy resources in our Europe West if we notice an increase of European-based customers. So instead of them reaching all the way out here to America to access their resources, whatever it may be, right? Maybe it's just e-commerce. Now we can place them in the EU. When it comes to data governance as well and compliance, we have to think about regions as well. If we're going to be servicing customers in the EU, we have data compliance a part of that region, or data sovereignty a part of that region that we have to be aware of, things like the GDPR. If we want to sell a SaaS appliance or application to the US federal government, maybe we want that in US-based data centers because maybe that's part of our FedRAMP, checklist, right? So regions, not only does it help you with high availability, placing things that have a redundancy, but it can also help you with your data governance and compliance, okay? All right, ACLs, just quickly. ACLs are the actual permit and deny statements that we put on our routers, on our cloud gateways, our VNets and VPCs. that'll filter traffic, okay, access control list. All right, another thing we have to be wary of if we're monitoring our network, we're doing our vulnerability scanning, doing things like Nmap, is peer-to-peer connections, or just network scanning as well, like NetFlow, things like that, or SIME. Peer-to-peer networks kind of indicate the sharing of files and resources without, well, they don't indicate. They are sharing files and resources without the need for a central server. But when we see peer-to-peer, that may indicate some torrenting involved, and there's some security issues with that. We don't want our users to have that ability sometimes, because that opens up an easier attack surface for things like worms, okay, when we enable peer-to-peer sharing. So maybe that's something we want to disable just to kind of harden our security architecture, make it a part of our defense in-depth approach. Air gap. Sometimes it's necessary to actually air gap our enterprises. Imagine your CCTV, imagine your security systems. If that's sharing the same subnet, the same resources as your enterprise, well, imagine your enterprise gets exploited and they take down your CCTV. So sometimes you want air gap networks that are completely separate from your enterprise, okay? This is protection from cybersecurity attacks, physical isolation, OT, IT. That's what I always think about. Your OT and your IT, in a perfect world, right, should be air gapped. Should be. It's not always the case. You don't always need it to be that extreme, but that's just an example, right? Okay, let's go ahead and do our check on learning. Then I'm going to take another break because I feel my voice going away as we keep talking. Let's go to our lessons here. Let's take this domain quiz. Let's bring up my chat, my Zoom chat here. Okay, question 1. What is the primary purpose of implementing VLANs within a corporate network? Yep, that's going to be C, to segment a physical network into multiple logical networks. Yeah, I know it's taking, that's not a bad answer there. Yeah, that's what it does. It does network segmentation for our campus, our land. In cloud computing, what is the purpose of using availability zones? We're going to go with D here. A is not like completely wrong, really. I mean, but geographic regions, when it comes to the cloud, they mean east, west, central. But remember, availability zones, like if you have AZ1, like availability zone 1, that's just a cloud data center. And if it says that's in Virginia, and then AZ2 is in South Virginia, that's still some geographic dispersion, but I know what they're saying here. Yeah, we're going to go with D. To improve fault tolerance and reduce the risk of downtime. Question 3. What is the role of a jump box in network security? So we're going to go with B here. That's going to be to provide a secure, controlled path for access to internal networks from an external source. So yeah, jump box. Remember, that's like almost like a man in the middle, but in not malicious way anymore, right? Question 4. Which of the following best describes microsegmentation in the context of network security? So let's check this out. Microsegmentation. So it's going to go with C here, right, guys? The practice of dividing a data center, this also happens in the cloud as well, okay, into distinct security segments down to the individual workload level. Segmenting services, right? Segmenting actual applications, microservices. Now, in the data centers, this does happen. And we have like networking tools like VXLAN, anyways, that we could get into. But question 5. What is a screen subnet often used for in network architecture? So yeah, B, that's what it used to be called, a DMZ, right? To provide a demilitarized zone with additional security for public-facing services. Question 6. What is the function of access control list in network security? So this is our permit and deny statements, right? So what do we got here? That's going to be A, to define rules that grant or deny traffic flow to or from a network. Question 7. How does an air gap enhance network security? This is physical isolation, right? Yep, good job. C, it is physical isolation. Last question here, we're going for that 100. In the context of VPCs, virtual private clouds, what are security groups used for? Yeah, we're going to go with C here. Remember, VPCs, that's accurate. That's kind of like the overall umbrella definition. I'm an Azure guy, so I call this VNets. So if you ever hear me say VNet, equate that to VPC as well, okay, guys? But awesome. That is 100. My voice is, I can feel it. I can feel it going away. Let's take another 10-minute break, guys, and then we'll come back. All right, let's go ahead and finish up domain 1 now, guys. So in this last section, we're going to go over zero trust, deperimeterization, and zero trust. We're not going to dive into like the actual NIST standard for zero trust. I think it's like NIST 800-145. Can't remember. I'll look it up. So just go over zero trust in general. We'll go over the merging of networks, and then briefly touch on SDN. I'm not going to break down software-defined networking as compared to like traditional networking. I'm just going to go over pretty much, hey, in SDN, cybersecurity, we have a single pane of glass, which means now we have to prioritize IAM to our SDN, okay? Let's do it. So deperimeterization and zero trust, they advocate for a security approach that does not rely on traditional network boundaries, assuming no inherent trust in any entity. So if you want to know the 3 core principles of zero trust, let me write them out here. So whoa, why is this so tiny? Hold on, let me check the settings. Font. Why is this font so small? Oh, okay. 1 second, guys. Let me get it back. Okay, so the 3 core principles of zero trust is never trust, always verify. So in these next slides, we're going to go over like, oh, wireless, wired, RF, all these different like threat vectors and ways to connect to a network and how zero trust relates to them. But really, if you understand these 3 core principles and apply them to those different connection methods and types of networks, zero trust makes a lot more sense. So never trust, always verify. What we're talking about there is that when a subject, a service account, user account, computer object, or just, or a computer, right, or some sort of device wants access to an object, it's going to go through the zero trust, what we call architecture, which is like a control plane and data plane with a policy administrator, a policy decision point. And what that is just pretty much saying is your authentication and authorization services, however you build it out. Every time a subject, wants access to an object, they must get re-verified. That means multi-factor authentication. Even if you're already trusted inside our network, we're going to re-verify you, maybe with a second, third factor. We're going to have contextual awareness built into our zero trust architecture, meaning if we see you're trying to sign in from a strange source public IP in a geolocation we're not familiar with, we're going to enforce some more factors of authentication. That's the never trust, always verify principle of zero trust. And then the other one is always assume breach. So when it comes to like threat hunting activities and the way you protect your networks, it's always a proactive measure, not a reactive measure. Now, it's not always perfect, but this core principle is always assume breach. Essentially meaning deploy architecture, monitor architecture, conduct training exercises and activities to assume that an advanced persistent threat is already living on your network, doing data exfiltration, and has persistence. Third is POOP. I'll write that out. Principle of least privilege. So you notice a lot of times this is like IAM related, identity access management related. So another core principle of least privilege, says always enforce the minimum amount of permissions to a user, to an admin, to whatever, for exactly what they need to do to perform their job roles. This also ties in RBAC, right? Role-based access control, principle of least privilege. This makes sure you're doing your security audits, making sure we don't have privilege creep, making sure that things like that don't happen, okay? And then, yeah, on the slide you see continuous verification. That's the never trust, always verify, right? Now, why do we need zero trust? Where did it come from? It came from the concept of our traditional network not being so traditional anymore, where if I were to draw it out in a very, very simple terms, or just a simple sketch, when you would go to work before COVID, imagine you're back in 2005, you're heading into your corporate office, okay? I was like 9 years old at the time, but I'm imagining, okay? And you want to do work-related things. There was no take your computer home, get on the VPN, access our Dropbox, access this portal from the end. There wasn't none of that. It was sit down in that office, and that's where you can access our enterprise resources. So that made it very easy for IT administrators to do security. Why? Because they just had to worry about inside their perimeter. Not that it was always easy, but you know what I'm trying to say, that the perimeter was right there. So essentially, this was our network for a long time. Router, maybe a firewall over here. Our switches, our internal architecture, our users, our VoIP phones, our access points, and then like our server farm. And that was it. So what did we have to worry about? Insider threats, of course, still phishing attacks, right? Stuff like that. But guess what? Everything went through this single point. It all went through that firewall router to make it inside here. That's it. But then what happened? As remote workforces, cloud-based applications, things started moving off-prem. Well, then we had, SaaS appliances, platform as a service applications. We had remote workers. Let me change the color there. Back to blue. That would sit at public Wi-Fi and they would access the cloud resources, access internal enterprises. So then we had VPN concentrators that pretty much opened up attack surfaces, right? Then we had to have DMZs, public facing stuff, things in our cloud. So zero trust came about because we didn't have that easy perimeter anymore. We had subjects accessing objects all over where we don't even have full control sometimes. Remember, in the cloud, we have this responsibility matrix, okay? The responsibility matrix that says what we have to protect, what the cloud service provider has to detect. So this is where zero trust architecture came into play, where it's like, hey, we don't have full control of where our subjects are accessing our network resources, our objects. So we're going to lay out in this NIST, right, the NIST standard of zero trust architecture and how we can protect our expanding enterprises that aren't so traditional anymore. So that's where it comes from, okay? Zero trust architecture. I have a 45-minute video on it on YouTube if you guys want to check it out too. Okay, so cloud and zero trust environments. Essentially, we just have a lot of different things we can do here. We can introduce like CASB. We can integrate our cloud service providers, IAM appliances into our on-prem, or opposite, right? Remote work in zero trust environments, making sure that our remote workers always have like encrypted VPN sessions. We're always re-verifying them. We have continuous monitoring. We have contextual awareness. The same way banks have for decades, where if we see a user trying to log in a foreign country, that should trigger, hey, let's enforce some more verification. Mobile, it's same thing. Mobile, what kind of endpoint security do we have on our remote workforce? Application control and context-based access, kind of same thing. With outsourcing, do we have MSPs coming in? Do we have external users coming in to do work and we're giving them external like B2B access? Sorry, that's another Azure term. This is CompTIA. Just external access. How do we segment them? How do we isolate them? Wireless RF networks in zero trust environments. So like true zero trust is like, oh, hey, we only trust our corporate Wi-Fi and maybe cell towers. Because what are you gonna do? Turn off, the ability? And any other public Wi-Fi, your corporate-owned phone will not connect to it, right? Okay, so the merging of networks from various organizations. So when we acquire, when we merge, we have external B2B users coming in, we have to make sure that our security assessments, our compliances align, that if they're meeting ours and we're meeting theirs, when we look at our tech stacks, how are we gonna federate properly? What are we doing? OAuth 2.0, do they have a SAML server? What is our unified security framework that we're gonna do with our two organizations? Cloud to on-premise integration. So when we're having users access cloud resources, or when we're in the cloud and the cloud's doing some sort of Entra ID, Active Directory sync, how do we make sure that that's secure? Do we have the data compliance and data governance we had on-prem extended to the cloud? Kind of like I was talking about, right? Where our EU users in the cloud and on-prem, are we applying GDPR correctly? Okay, now moving on from that zero trust, data sensitivity levels. So this kind of dives into like DLP, right, guys? Where how can we know what data to stop from exfiltrating if we don't categorize it correctly? And how can we categorize if we don't know the sensitivity level? So we need to have data classifications And with those data classifications, we should have layered security controls. Things like mandatory access control on a need-to-know basis, okay? We need to have policies in place. So we need to have, again, our data governance in place to say, this sensitive data, who has access to it? Are they aware? Are they signing AUPs, NDAs, the proper documents to know how to handle this sensitive information? Now, I come from a government background, so this is like real easy. Every time you go work at a different DoD-related site, it's kind of all the same, right? We have secret, top secret stuff, and it's all kind of handled similarly. But in the private sector, a lot of this comes from the industry that you may be in. What's our data sensitivity level if we're in the finance sector compared to healthcare? What's our governing laws? If we're in California, there's California acts. You know, if we're operating in Europe, there's other things in Europe we have to be aware about. So we have to make sure we're handling things properly based on our governance, our region, and the compliance we may have within an industry. And then classifying it as such. Okay, mergers and acquisitions, they pose a unique challenge. Kind of already talked about that. Just making sure the tech stack works together and that it meets certain compliance when you're doing the merger or acquisition. Cross-domain solutions. So sometimes from a lower classification to a higher classification, you have to send information, data. So maybe we have a CDS solution where we have a staging environment on the unclassed system, and our CDS solution that's merging the two grabs files from that staging solution, runs it through a filter. Maybe certain file extensions aren't allowed. Maybe it runs actually does some content filtering there, inspects it, says, yes, this is allowed to go up. Now, maybe that doesn't work both ways though. Maybe at the higher classification level, we don't want it coming back down. Something we have to think about and configure. And again, this is not up for you to decide. Look at your industry compliance and the rules and regulations of which you're governed by. And as a cybersecurity professional, if you're jumping industries, it's not one size fits all, okay? Okay, federation. So high level. I'm not going to get into how OAuth 2.0 works, how SAML works, how OpenID works. We're just going to get into what federation does. So federation allows organizations to use IDPs and trusted connections to deliver a single sign-on experience. Now, there is a distinct difference between SSO and federation that we'll go over in the later domains, but federation at a high level uses protocols like SAML, OAuth 2.0, OpenID Connect to create a trust relationship that then uses identity providers to allow access to third-party resources. That's as far as I'm going to go. Just imagine when you sign into a website using your Google account, your Google ID, that's federation, okay? Directory services. So directory services, that's LDAP, that's Active Directory. That is your enterprise solution for IAM, okay? It's centralized, and it may have, if we're doing Active Directory, there's a lot of protocols we've got to be aware of. LDAP, NTLM, Kerberos, and the different security implications of those. If we're going cloud-based, that's all web-based directory services, okay? So API requests, things like that. All right, now finally, let's talk about SDN. I forget, this test came out in 2021, OpenSDN. Okay, software-defined networking. What software-defined networking does, it is a shift from traditional networking where I'm SSHing into individual devices to troubleshoot and manage. And now I have a single pane of glass to apply routing policy, to apply QoS, to do centralized upgrades, to have a centralized place to gather network telemetry and make decisions based off that. And because of that, that centralized control plane, single pane of glass, we have IAM issues we may be aware of. So if I'm deploying SD-WAN or Cisco Catalyst Center, which used to be DNAC, how are my APIs requests from my northbound interfaces being handled? Is it secure? Am I putting authentication on it? And who's getting access to that web portal? That's kind of what I want you to think about when it comes to SDN, okay? I'm going to quickly, we're not going to go over that, okay? I don't think it'll be relevant for the exam. All right, let's do our quiz. So we're at, save and exit. We're at domain 1.1.4. And let's go ahead and take that domain quiz. So question 1. Which technology is essential for supporting remote workforce while ensuring network security. Okay, so I'm thinking B or D here. 1 second. For supporting. But with the remote workforce, guys, you know, directory services are supposed to be on-prem, right? So we're going to go with cloud-based services. Cloud-based IAM is what I would call it. An example of this would be like Microsoft Entra ID. Do I still have my portal up? Nah, I don't. That's okay. I'll show you that later maybe. We have another cloud section. Okay, question 2. In the context of merging networks due to a merger or acquisition, what is the first step in ensuring the security of the integrated network? So imagine we're about to merge or acquire a whole other enterprise, a whole other network. So what are we first going to do? We're going to assess them, right? Assess how their security meets our security. And are they in the same compliance as us? We're going to assess our data sovereignty with them. So we're going to go with A here. Well, let's read the other ones. Implementing new firewall, no. Disconnecting, only. Definitely not C, right? So yeah, we'll go with A here. That's the best answer here. Question 3. What is the role of federation in the context of network security and access management? Remember, access management, I keep saying it, IAM, right? That's what you guys to think of, access management. That gives us a single sign-on experience. But you see how this says seamless access? I like that better. We'll define this later, but SSO and federation are not a one-to-one match. We'll define that later, okay? But yeah, it's going to be D, to enable seamless access to resources across different security domains. Question 4. Which scenario best demonstrates the concept of deperimeterization in network security? So that's kind of what I drew out. Remember how we had all those different cloud-based, SaaS-based resources, remote workforce now, compared to our traditional network. So let's read. Company uses a single centralized firewall. No, that wouldn't work, right, in our deperimeterization. B sounds good. Let's read C. All user authentication is managed through a single directory service. No. Via hardwired. No. All those are examples of traditional networking, right? So it'll be B. Employees access corporate resources from various locations using mobile devices. Okay, question 5. What is the primary principle behind a zero trust security model? Trusting all devices? No. Ensuring only devices outside the network are authenticated? No. Never trust, always verify. Oh, cool. I wrote that out. Awesome. So yeah, it's going to be C. Good job. Oh, shit. Sorry. I'm reading your guys' messages too as I'm going through here. What is the primary security advantage of using SDN overlay networks? I didn't go over this, so if you don't know it, that's okay. Again, this test came out in 2021, and it's changed since I made these slides back then. So I didn't go over SDN overlay. And I really don't see the need to, okay? So we're just going to submit an answer here. Oh, I got it right. We're going to move on, okay? I don't like to go over things that won't be necessary for the exam, guys. You'll see that. If you want to know about this shit, just let me know. So hybrid SDN and open SDN. Yeah, open SDN is open source. Yeah, whatever. We'll just go with C. Yeah. Okay, B. The integration of traditional network. Oh yeah, hybrid SDN does both. Okay, that's okay. It really doesn't matter. That's actually, SDN is my bread and butter. That's what I work on my day job. I'm a network engineer, but it's just not important. Okay, let's go ahead and take another 10-minute break, guys, and then we'll go over domain 1.2.